So good morning. Welcome to the Missenden Spring Weekend online Zoom presentations. I think I'm the first of the four, aren't I, Mick? He nods. What's beauty. So I get the honour of starting things rolling. So I've been asked to give just a talk on JMRI, and if you don't know what that is, you're going to find out in a minute. A little bit about what it can do. Obviously, in an hour or so, we're not going to be able to teach you how to work it. That's like when we do a weekend course on it. And hopefully, we'll be back to those before too long. Certainly, October weekend, fingers crossed, we'll be back at Missenden. We'll see. Mick will tell us more maybe later. But so I'm going to talk for about an hour or so, and then I suggest we have a short coffee break, and then after that we can go on with Q&A and discussion for, up to another hour, I think, or so, or up to about 1 o'clock, I think is the idea for those who want to stay that long. So I'm going to share my screen. Start off with a little presentation about JMRI. Right, so you should all be able to see my presentation slides there. I'm getting some nods, that's good. So JMRI, Zoom online. So what is JMRI? It's actually a computer program to connect to the model railway, in a word, or in a few words. And you can use it to control some or all aspects of the layout, and it's quite flexible in the different ways you might use it. You can use it to create on-screen control panels, to control the points and the signals. And you can have those either instead of your normal physical control panel mimic diagram with your switches and buttons, or as well as. So your layout could still work if JMRI wasn't there if you've got a physical panel. And in fact, the layout behind me, which I shall introduce shortly, does in fact have both. It can be used to program the addresses in DCC locos if you use it with a DCC layout. For DCC layouts, you can drive trains via remote devices, smartphones, that sort of thing. Control the trains, and if you want to go the whole hog, you can go for full automation should you choose to, but that's not a requirement of using JMRI. So what does it stand for? It stands for Java Model Railroad or Railway, depending on which side of the Atlantic you are, I guess. Interface. Whoops, I pressed the wrong button there, excuse me. I'll just go back to where I was. So that's what JMRI actually stands for. What's Java then, if you're not a computer programmer? Java's the computer programming language in which JMRI happens to be written. And that's where the J comes from. And if you want to know more about that, lots of stuff online, just Google Java if you're not already familiar with what it is. But that's under the hood, if you like, in JMRI. To use it, you don't really even need to know that. Java's a good system for allowing portability to different computer systems. So you can use JMRI whether you've got a Windows computer, an Apple Mac, a Linux computer, or a Raspberry Pi. It can be made to work on all of those. In theory, it's not so good for the best, fastest performance because it has to go through this Java thing. I'm not going to go into all the technicalities of that. With modern fast computers, actually, you don't notice the difference that much. And using Java, these days, you can get it to look pretty much the same as the way the underlying computer looks in terms of the interface when you bring up dialogues and things. So that's really all we need to say about Java. Just Google it if you want to know more about what's going on under the hood. So the history is it started in the just early 2000s, I think, 2003, 2004, 2005, I forget the exact date. And some computer programmers who were also model railway enthusiasts wrote a set of, if you like, routines to allow other programmers to do their own programs to talk to their model railways. That's why it's got the eye of interface in. As first written, it wasn't really a complete program. It was just a collection of bits that would allow other people to interface their own programs to. And then Mr. JMRI, if you like, is Bob Jacobson. He's in the US, so it started in the States. And Bob is still very active. He is Mr. JMRI and drives the whole project. huge project. So you'll find a lot of JMRI uses US terminology. So you'll get an end bumper rather than a buffer stop. However, as time has gone on, there multi-language support in it, and there is some UK terminology sometimes you can find. But if you're switching a turnout or a point, both of which terms of course we use in the UK, whereas in the UK you'd be normal and reversed for the two positions of JMRI uses the American terminology of thrown and closed. So you have to get a little bit used to some of the internal US terminology. It's an open source project, and that means anybody who wants to get down the learning curve of how to do it can join the project and can contribute to JMRI. And for those who want to see the actual source code, how it's written, it's all there, it's all on the internet. Anybody can see, anybody can contribute. And over the years since JMRI has been going, hundreds of people have contributed to it, including quite a few from the UK. Now, this is by no means a complete list. Andrew Crossland, who's Mr. Sprogg, did a lot of this support for the Berg C-bus system originally, together with Bob Jacobson himself. Nigel Cliff has had quite a lot of involvement. That's another UK member in terms of decoder definitions and signalling and so on. And Kevin Dickerson did the UK signalling system and quite a lot of other stuff that's in JMRI. Kevin Dickerson you may know from Coastal DCC. He now runs his own business, Coastal DCC. And you see him, it shows. Steve Young is more recently has been very active in updating UK support and support for the C-bus system and other things as well, improving things. So he's currently active in the UK working on JMRI. And I'm sure there are other people that I'm missing out here. So apologies to anybody who I'm missing out on this list, because there are so many people involved with JMRI and this slide's a while old now. You just can't keep up. And others, as I say here. So we'll look at a couple of examples of what can be done, but also we're going to use the layout here as a live example. I'm going to be brave and demonstrate it live, see what can go wrong. These are taken from the JMRI website. JMRI website has got lots of information, and as an open source project, it's better documented than most, I have to say. So this is someone actually using JMRI to create the look and feel of the real signal box or tower in his case, as this is an American implementation. And it's a lot of effort, but you can do it, get it to look exactly the look and feel you want. And this guy, I'm not sure whether the typewriter's actually interfaced to the layout or not, but he's actually used JMRI behind the scenes to interface a real mock-up of the signaling system. And there is also a society, the Swindon panel, that have rebuilt, I think it's the Swindon Powerbox panel from the 1970s vintage, and that is using JMRI behind the scenes as well. So you can interface it to real hardware from the signaling end. These are some examples which normally if I'm teaching the course and we actually have a look at these examples. But in case of time today, I'm just going to use the layout behind me as the main example. JMRI has several what we might call components in it. There's Decoder Pro. Now, a lot of people use JMRI for Decoder Pro and nothing else. For those using DCC, DCC decoder inside has lots of settings, otherwise known as CVs, configuration variables. And if you want to change the acceleration rate of a loco, you've got to remember what CV number to program if you're going to do it for a handset. And most manufacturers of DCC systems will let you can change those values from handset. But if you link your layout to JMRI and use its Decoder Pro capability, then you can just go in and it'll say change acceleration rate. You change the acceleration rate and you don't need to know what CV numbers for. It does all that under the hood, and it keeps a record of all the settings of all your locos and what it calls a roster. So a lot of people use it for that only and nothing else. But it also has a thing called Panel Pro, which is what I'm going to show mainly today, which is for doing your on-screen control panels. that can be, if you're just using a control panel to work your signals and your points, then of course the traction, the trains could be analog DC or could be DCC, because using it simply for a control panel in that way, you're not necessarily trying to drive the trains from the computer, and therefore it doesn't matter how the trains are actually being driven. There is a thing called Sound Pro, which I've never played with. The sound I've used has been the normal DCC sound built into the locos. I believe what Sound Pro does is allow you to have some speakers under the layout, which are sort of phased, and JMRI will work out where the train is to use the stereo sort of effects. But it's not. I'm not sure whether it's still supported and how well developed it is. So I just mentioned that really for completeness. Now, the thing to bear in mind is that those three things I've mentioned there are not separate programs. They are all features of the one JMRI program. So if you load up Decoder Pro, having installed JMRI, from that same window that you've loaded Decoder Pro in, you could load up a control panel and have the two up at once. And likewise with Panel Pro, if you load a control panel up and go to the menu, you could load your roster in Decoder Pro. They're all one program, they're just different ways of going into it. And if you go for like the full automation, which I shall partially try and demonstrate here, then you're combining the two, because you've got the Panel Pro, the control panel that's showing you what's going on the trains running and controlling it, but it's also using the roster potentially from Decoder Pro to actually drive the trains. So the two kind of come back together then. So you get different menu options on the main window depending on which of these you load, but you can get to everything, as I say there. So that's really the quick intro to what JMRI is. So what you should now be seeing is an example of a JMRI control panel on the top of your screen and a view of the layout, or one end of the layout anyway, on the bottom of the screen. Now, just to introduce the layout, this layout is called Missenden St Mary's. It was originally conceived by Chris Langdon and is still owned by him. The idea was to showcase the various things we do at Missenden. So it has the handmade track done by Norman Solomon, and you could just see the quality of that track just even on the webcam there. Electronics and electrics, as we do at Missenden, it demonstrates. And baseboard construction. Underneath is the method Barry Norman has shown us with the two layers of ply and so on. So the idea is to showcase various things that we learn at Missenden. And over the years it's developed, it's got a little bit longer, and I've added a fiddle yard to it so that we can run it for these sort of demonstrations. So the trains have actually got somewhere to go. It's a pretty crude fiddle yard with 4 roads, where in fact you can see the layout on the diagram at the top. It's just got 4 roads. And a little throat there, but it allows us to operate that. So Chris very kindly lets me look after the layout at the moment. He actually doesn't have space at home to put it up fully. And before we all got locked down, Chris would come up occasionally and work on it here as well, where I've got room to set it up. And we take it to 1 or 2 shows, not really as a fully completed exhibition quality layout, but to demonstrate A, what we do at Missenden, and B, the JMRI automation aspects of things. And so we've had it on the sort of Missenden stand, if you like, showing things. So what I'm really going to do now is take you through some of the things that JMRI is capable of, and which we teach people how to do when we do a whole weekend on it. So if I take, this is what we call edit mode, and this is how you work. This is a part of JMRI called the panel layout editor, where you use the look and feel pretty much that JMRI provides you. So a turnout is always going to look like this, but it also, as you build the layout up, JMRI automatically works out the connectivity and what's connected to what and so on. And you know, if I wanted to add another turnout, I'd just go up to the top here. Where are we? Left-hand turnout, and I could just stick one on like that, and then I can move it around, and I can build up my track diagram to correspond to my main layout. And JMRI works with pretty much any DCC system out there, or any layout control system out there that has a computer interface. So very commonly used is LocoNet with the Digitrack stuff. The interface, depending on the manufacturer, can be the old-fashioned serial RS-232. Most commonly is USB. Some also have Ethernet. So you connect it to your computer by whatever mechanism the manufacturer supplies. And there's very few DCC systems out there that you can't interface. Lens and ExpressNet. I'm using the Merck C-Bus system because that's what I use. But everything that I'm talking about here is applicable, whatever layout control system you use. And JMRI can talk to more than one control system. So whilst I'm using the Merck DCC system as well, which communicates over C-Bus, so the one connection from the computer covers both. But quite commonly, I've helped out with layouts where perhaps they're using, say, NCE or Digitrax or whatever for their DCC system, but using maybe C-Bus to control the points and signals. And JMRI is quite happy. You just define two interfaces and you can split the two. They don't have to be the same. And as I mentioned earlier, if it's an analog layout with DC, whilst I think there is work going on to see how JMRI might control those trains directly, its train control is really built around DCC. But there's nothing to stop you using whatever system you like, whether it's DCC control of the points or a layout control bus like C-Bus or LocoNet, and have an analog layout that's controlled by a JMRI control panel. So I'm just going to remove that thing I added there. Just where are we? Delete. Yeah. So and this layout diagram is built up over quite a lot of time. And as you see, it mirrors the actual layout with the turnouts and the track. I've added the signals. JMRI has quite a sophisticated signaling system. So if I were to change this turnout, if we look at this signal here, which is currently yellow because we're running into the track in the fiddle yard, and the block here is occupied in fiddle yard 1. So if I change the point here, that signal goes now to danger, because it's blocked ahead. And I haven't implemented it here, but you can do the clever calling on stuff with a permissive by defining it as permissive, and you could have a calling on head there if you wanted to go that sophisticated. And now the route's set down from the head shunt down at the bottom left here, so the signal's at yellow because the next signal down the route that's set is at danger. And if I set this back into the fiddle yard road, we're now yellow here, and the one down here automatically goes to green. So you can set up all the signaling to work automatically. And the signals themselves could be semaphore or colour light. And you can, JMRI is pretty much capable of anything, and how sophisticated you want to get and how much time you want to spend on it is up to you, because it's quite a big learning curve. I won't be dishonest with you. There's a big learning curve in learning JMRI. But because of that, it's capable of doing pretty much anything. So if I want to have semaphore signaling with the right delays and everything, I can do that. In fact, you can see down on the picture below, there's a semaphore signal there, which normally works, but I think it's come detached below. Maybe I'll try and fix that when we have the coffee break so I can demonstrate it. And so although the indicator on the panel here is just a, in fact, if I change this point here, we should get, but I didn't for some reason. It's always true when you try and live demo. No, this is where again JMRI is quite clever. So I've put an extra rule on that signal that says don't pull that signal off to green if there isn't a train sitting in the platform, because there's no point, is there? The signal wouldn't pull that off if there was no train in the platform. So I would have to put a train in that platform, which I'll do in a minute, and then that signal will go green. And I've also programmed a little delay, so this, when after the route is set, there's a delay before the semaphore pulls off, as it would be if a signalman was pulling the lever. You can put icons on the screen that look like semaphore signals if you prefer as well. It's got all those capabilities. So JMRI has built in a lot of logic stuff you can do. If this do that, if that do that. And then if that still won't do everything you want, you're trying to do something really clever, it has a built-in scripting language based on the Python language for those who are into programming. So you can write your own scripts to do whatever you were. And ultimately, because it's open source, if you really want to make it do something strange and different, you can modify JMRI itself. People are encouraged when they add new features to feed it back to the, for the whole community, so everybody gets the benefit, and that often happens. But also some people just tweak it to their own needs. But yeah, you really need to be a programmer to be able to get into the Java to do that. Whereas of course, just to use JMRI, you don't have to be a programmer at all. So Let me just make this a bit smaller so we can see what's going on below. So what I've also got, as well as the control of the turnouts, which I've been demonstrating here just by clicking on them, and I can, and the signals, rather than, you can have it, some people prefer to operate the signals themselves, so you don't have to have the signal set to automatic like I've done. You can require the operator to actually click on the signal to pull the signal off if you prefer. It's however you want to do it. Another feature you can do is you can use entry-exit routing, which I've got not completely implemented on here, but partly. So if I want to go from, let's say, platform 2 down here, and I want to go up into this fiddle yard 2 up here, I should be able to click on the little button below the first one, which starts flashing, and I want to go up to here, and it changes all the points along the route and allocates it in green for me. And then as I bring a train through, let's give it a go. Ready to go. Where am I? Platform 2. I've set the route to, haven't I? So you should be able to see the little DMU coming out there. We've also got block detections. That works through the C-bus system, so the track goes red when it's occupied. I'm sorry if the train's a bit jerky. That's because I'm actually sharing a screen that's showing the webcam program rather than using it in Zoom native, so I can get JMRI over the top. So we can see that it clears the allocated route as we go down. And it shows what's occupied, and the signals are automatically going to red behind the train. And although I can't see what's going on down there unless I stand up and have a look, but of course I can see, I can slow it down. And then as soon as the throat bit goes inactive, I can stop the train now and say, okay, that's got there. So that's demonstrating using JMRI with a manual control of the train, and with the entry-exit routing there as well. So that all works quite nicely. The other thing JMRI can do is it can actually track the progress of a train. So if I tell it, that's my 158 DMU here. I put that in there, and this doesn't always work 100% because you do have to have everything working just right with no loss of contact and no thing. So I'm going to set the route now back on the up line as it should be. I've clicked on that twice, which was silly of me, so now it's gone back that way. And we'll see the signals. We've got a green signal through a yellow signal into platform 2. So I'm going to bring that train back. Let's see, yeah, that looks good. And what we should see, with any luck, didn't work. Hold on. I think I've been messing around with ways of picking up information from RFID tags and things, so I'm just going to manually override that there for the moment, and it should bring it the rest of the way, I'm hoping. We'll soon find out. It's always the problem with a live demonstration, isn't it, as to whether it's actually going to work properly. So we can see that tracking down the route. So my demonstration of the tracking has completely failed, probably because of things I've been doing on the layout. But what that should do is enable you to track the train around the layout, and if you have it all the blocks set correctly. You'll notice a little, right at the end here, just as I was approaching the buffers, this thing changed from the circle to the square. There's a little infrared detector, so I know when the train's just getting to the buffers, and I know now it's time to stop the train if I can't see it. So we've shown a little bit about signaling. We've shown a little bit about operating the layout from JMRI. And what I'm going to do, what have I got there? I've got another loco. I'm going to move from there. We haven't come up the goods line yet. We'll come the other way with this one for a change. And what I've done, you can do extra logical things in JMRI. Now with the double, there's a double slip across the middle here. And it's a bit fiddly clicking on the double slip to work out which way you want it. So I've done the settings in JMRI so that you actually control it from the outer points. So if I have both outer points set to normal in our terminology, rather than thrown or closed, which is JMRI, you can see that it actually sets the double slip straight. If I set this turnout to be across, to be reversed, it automatically adjusts the double slip to use that as a crossover. And you can do that with any crossover. You can make the two work together, which is logically. And likewise, if I do the same with this one here, again, it sets it to work as a crossover. If I have both turnouts done, it automatically sets the double slip to be straight across the middle. So the operator doesn't have to try and work out which way to set the double slip. They just set the turnout to the way things are going to work, and it just works. So you can see we've got a green signal down here at the head shunt, which is where the class 20 here is sitting. And I'm going to bring that up this goods line, across the double slip, over to here, and all the way down into the end of fiddle yard 2. Of course, I do have to select it on the control before it's going to move. And again, we can follow that now on the tracking, on the layout. We can see the blocks going occupied as it proceeds down the layout. So this is using JMRI very much as a control panel for the layout. You could have somebody working a signalman and other people driving the trains, as one might do when operating a layout. And then we'll look at in a minute and see if I can get any of the automation. I haven't tested the automation for a while, so we'll see what happens. It could be interesting. So that's disappeared into the fiddle yard on the right. Now you'll notice that because there is a valid route set the other way, the signal's now gone to yellow now that there's a train in the fiddle yard for it to come out with the route that's set. The one downside of automatic signaling, of course, is that sometimes those signals will pull off when you don't want to. So what you can do, I've got it set so that if I can actually click on the signal and I can put it into a held mode so that even if there's a valid route, the signal is still at danger. And that can you can use that to get more realism with the signal operation. Okay, now the next thing you can do is look at automation. Now there are various ways in JMRI of automation, because JMRI has the capability of driving trains. I haven't got it set up to do that at the moment, but you can drive it from a smartphone. You can drive it from an on-screen throttle alarm. I can do that here. So if I go to, actually, let me show you first. I'm just going to go to the main. That's the main Panel Pro little window where you get all your menus. And you can see I can bring up the roster here, and I'll bring that across here. So that is effectively the list of all the locos and their DCC addresses. And this is where you can program the CV settings of any loco. So I've pulled it up from the Panel Pro main window, which there is also on your desktop. When you've installed JMRI, there is a dedicated Decoder Pro one as well. So if I were to bring up, I know, the bubble car, which is behind me in platform 3 there, if I just bring that up. So if I go to here, I can change the address. I can change for example, the acceleration and deceleration here, and I don't have to know what CV numbers they are. I can either do this with what they call programming on the main, which is how the loco is at the moment on the main layout, and it will just send the new value to it. But if I want to read stuff back and also get confirmation of anything I change, I put the loco on a separate programming track. And in the roster, I actually tell it here, down here, whether it's on the programming or the main. So we tend to talk about using Decoder Pro and setting DCC locos when we do the DCC weekend course, rather than when we do a JMRI weekend course, because there isn't enough time in a JMRI weekend course to cover this and the control panel stuff. So I'll take that off to one side. Actually, I'll do that. Now what I can also do, I can do tools, let's have a look. Throttles, and I can have a throttle here. Just come up on my other screen, but there it is. So I can select either from my list. This comes from my roster. So if I were to go down here and find bubble car, it knows that's address 121, and just, yeah, it's a long address 121. So now if I actually do that, we should see PCS. There we go. Of course, it's going the other way at the moment, so we'll put it into reverse, which is actually towards us. And I can now, we can see that bubble car behind us moving down the platform. So I can do it with an on-screen throttle with JMRI. So now JMRI is driving the train, although albeit I'm working it manually from here. And that's the first step to having the computer control trains. JMRI also has the capability to link in smartphones with appropriate apps, so you can drive it from a smartphone. Personally, I don't find a smartphone a very intuitive thing to actually control a train with, because I like to have a physical knob to drive it on a handset. But the great thing about smartphones is that they get the youngsters interested, because they're all into doing everything with their smartphone, and we desperately need youngsters to be interested in our hobby. So actually promoting the fact that we can drive the model railway with an app on the smartphone, the youngsters love that. So that makes it a very good thing, I think. Am I for time? Oh, we're not doing too badly. Okay, so down here, this little part of JMRI is, if you're using the Merg C-bus system, it just tells you which anything that's got a session number is a locomotive that we're actually controlling, and it tells you what speed it's currently doing, forwards or reverse, and what functions are turned on for all the different locos. So these are the ones I've been driving and messing around with. A lot of people for their DCC address will tend to use the actual full numbers, or 4 digits of the number on the side of the loco, but I can never remember that many digits. So because I very rarely have more than one loco of the same class, I tend to use the class number as the DCC address. But you know, you can do whatever you like, and that's just an aside from JMRI, really. So let's look next at the options you've now got for automation. Now you can write inside JMRI a script, which is like a little computer program written in a scripting language called Python, which sits out. It's not part of JMRI itself, but then in JMRI you can tell it to run that script. And so you can actually make the trains do whatever you want to do and get as clever as you like about how you manage trains not crashing into each other and all that sort of stuff. There's also supplied with JMRI is a thing called YAT, which is yet another auto train. That's a very sophisticated script written by one of the JMRI developers, Dave Sand, and that allows you just to create a file of movements, and then his program will run them according to your commands. That's fairly recent. I've dabbled with that. I haven't really done much with it. And then you've got a thing called the dispatcher, which is the most sophisticated way of doing automation. Now in the dispatcher in JMRI, again, you create a list of movements, and JMRI will run those movements for you according to all the rules you've set up. Now you have to set up a lot of rules. You have to set up permitted maximum speeds for every block, speeds for approaching signals of particular aspects. And JMRI will use all those rules to drive your train to the signals. And that's what I'm working towards with this. Everything has to be working 100% in terms of all your signaling has to be just right. I've got a little bit to do to get the dispatcher fully working on here. So for automation at the moment, I'm using some scripts that I've written to actually run the layout in an automatic way. So I'm just going to tell it what trains are in. My script needs to know what trains are where to start with. So I'm going to tell it that one's there. What one have I got there? I think I've got that one there. I've got that one there. Platform 3 is the bubble car. That's the 158, because these are the actual DCC addresses of the trains I've got in the different places. So we'll see how it gets on. And then let's have a look. So I've created this window, which will sort of hide here somewhere perhaps, so you can still see everything. This is really just another JMRI control panel. It hasn't got any track on. I've just put my script will update this with the status of what's going on as the automatic trains run, and it just lets me see a bit what's going on. So we'll see if anything actually works, because I say I haven't tried this automation for a while, so I haven't run it for a bit, so we'll see what happens. I can run it with the sound on or off. I'm going to have the sound off for the moment. Some of the trains have sound, and I can, the script will run them with the sound and turn the sound on and help hoot the horn at the appropriate time. But that's probably going to be a bit awkward in this format where I'm trying to talk at the same time. You'll just get the racket of the trains instead. So I'm going to hit the start button here, and let's see. So it's cleared down the status of the 5 trains here. And then, so what I've built into my scripts is a random dwell time at each end so that it doesn't run a lot of people like to run a fixed sequence, and you can certainly do that with this, an absolute fixed sequence. And of course, we all know that real trains run to an absolute timetable. So, but as a train spotter sitting on the end of a platform, it looks a bit random to you, and the pleasure is you don't know what's going to come around the corner next. That's not true of the modern train spotter with his app and directly onto Network Rail's system. He knows what's coming around the corner. But so I like to have a little bit of randomness. I don't know which train's going to come down yet to an extent. Now we can see that you see it's tracking it this time. So we've got the 33 is coming down here on the layout, heading towards us, and that's being controlled purely by the automation now. I'm not driving it, and it'll come into view in a moment. There it comes, slowing down into the platform. Sorry about the jerkiness because of the way I'm doing it. If you look behind me, you'll see it a bit smoother. I think if you can see my face picture in the gallery, and if you've got 2 screens, you can pin that to your other screen. So it's slowing right down. It slows to a crawl in the last block and waits for the little optical sensor. When it gets the optical sensor, it brings it smoothly to a stop. And that's all under control of the automatic script. And now you can see it's changing the points, getting ready for the next move. And in fact, the 158 now from platform 2 is on its way towards us. Okay. So live demos, things that can go wrong. My scripts at the moment assume the trains are a particular way round on the layout. That 158's on the layout the other way round, so it's trying to drive into the buffers at the moment. So I'm just going to do a hand of God and turn it round. Excuse me. Right, so now it's going the way the script thinks it is, so that should work fine now. So that's away. I'm also just going to check something else up the other end. And what this is telling you here is inside my scripts, I've got it allocating various parts of the layout to that train so we don't get a conflict. At least that's the theory. And so with the random delay at each end and them trying to grab the different sections, we get a little bit of randomness about which train goes when. And these bits here are just showing me which train has got the allocation of which section of track at any given time. And on it churns, semi-randomly, operating the various trains. So what I've shown there is really in a fairly short time some of the things that JMRI software is capable of working with the layout. And of course you don't have to use JMRI all the time. One of the great things about Dispatcher, and you could write it into an automation script of your own, I haven't done it on this one yet, is that with the Dispatcher, any train that's running automatically, you can click into it and say, turn this one over to manual control. So in amongst your automatic sequence, you can actually drive a train yourself to the signals, because the signals will be running so you don't conflict with other trains.
So rather than just being able to drive one train on your layout, you can actually have multiple trains running, but you and other people, other friends or whatever, can be manually driving a particular train. You can also have, the other thing I've got programmed here, you see the 158 has come down to here. You can't see it at the moment, but it's actually stopped at the signal because it's red, and it's holding now until it's waiting for the up station to be free, because probably the 121 has stalled. So it's actually waiting for that to come out of platform 3, because the bubble car has actually got the allocation of that route. So once that's cleared, then the 158 will head on down into the station. And all that's programmed into the script. With the dispatcher, JMRI would work all that out for you, and it would do all that. And that's my aim, is to get that working as well. But you can also program with the dispatcher. You can say this particular train, you create a set of parameters for a given train, and you could say when you get to this station, stop, turn over to manual control for shunting of the local pickup goods or something like that. And you have an operator does the manual shunting and then returns it for automatic to the rest of the layout. So, I quite enjoy the automation because it's the challenge of getting it working. And then once I've got automation working, I can sit down and do some modeling or whatever whilst I watch the trains go by, which is quite satisfying as well. So I think probably we've got about 15 minutes till we're going to take a break, but I'll throw it open for some questions, or if there's particular areas I haven't covered that you're interested in. Mick, how do you want to do the questions, or whoever's hosting, Mick, Mark, or Simon, or whoever? Do you want people to put their hands up? Do we allow people to unmute themselves? How do you want to do it?
It might be better, considering the numbers we've got, Pete, for people just to unmute themselves and ask questions. Yeah. But hopefully they'll understand that they can't all ask a question at the same time.
Yeah, I think so. I'm just going to check there's something strange going on at the other end. I'm just going to check that. Then if people dive in and they can unmute themselves.
Yes, Andrew.
Yeah, I wanted to ask, is it possible to use JMRI on modular systems where you have multiple instances of the software communicating with each other rather than just one program running the entire layout? So could you take Missenden and St Mary's and have one running the station and another JMRI running the fiddle yard and have the two of them communicating with each other?
Yes, you can do that sort of thing. You need to be a bit of a techie to get that all set up and working, but it can be done. I was involved in a very large layout called model of West Ealing in the 1970s, and we had, I think there was 3 computers running JMRI. One was running the main part of the layout, which was a 4-track main line. One was running the fiddle yard, and one was running the branch line. So the idea is you could have different signalmen operating each one. So, and we had to do, and what we did is they were all on the same, connected to the same C bus, and there was one C bus for the, so all computers saw all messages. Was how it worked on the layout. So that, and at the boundaries we had to do some clever stuff so that the signaling worked, because each computer loaded the same JMRI panels but only showed the one for its own particular one, so the logic worked layout wide. And then we had some logic which Chris Noble wrote, which I see he's with us, which at startup it would know which one it was and just enable the bits that applied to it and show the right panel. And so we had to do some clever stuff to get the signal logic to work across the boundaries. However, that layout was not full automation. That was purely people were manually driving the trains, and the JMRI was control panel. So it was doing all the routes. We had all the block detection. We had the route setting, and a lot of stuff like that. I'm not sure that if you could write your own scripts to communicate to pass control of a train, I guess, from one to the other, or if all of your JMRI instances are on the same bus anyway, you might adopt the bit like you do kind of when you're manually driving a train, that the same JMRI instance would control a train for its entire journey, but drive it towards itself or something like that. You'd have to get clever in your own scripts. I don't think the built-in dispatcher is capable of splitting its logic between different computers. But of course, you know, you could get in there and change things. So yeah, it's certainly possible to have more than one computer run instance running JMRI, but you've got to dig in a little bit deeper into it to get it to work the way you want, I think. Does that sort of answer that question a bit?
Graham Stacey, you've sent a question on chat, but I see you've also unmuted yourself.
Yeah, I'm just curious to know what point motors you're using, and presumably they are DCC items.
Right, so what we're using on here, because it's a demonstration layout, it's actually got a variety. So the original ones, which I think Norman Solomon fitted and wired up when he built the track, are mostly the oh, the name of them now. The very old Fulgurex. Fulgurex, yeah. There's quite a few Fulgurex on here. There's one or two that have been replaced by Cobalts. There's one or two Cobalts on here. We haven't actually got any Tortoises, but we've got the Cobalts. And then in the fiddle yard that I've done, they're all servos. And we're controlling all those via C-bus, not from the DCC. We're controlling them from C-bus. So we have, so we have C-bus motorized point driver modules to drive the Fulgurex and Cobalt, which could also do Tortoise. And then we have the C-bus servo control modules driving the ones that work on servos.
Yeah, because I tried the Cobalts and I found them not as quiet as you would have thought. I mean, which of those are the sort of quietest in operation?
The servos are definitely the quietest of those.
Yeah, okay. Yeah, sure.
And actually for points, you want analog servos, not digital ones. The reason is that what we do with the C-bus control system is once the servo has moved and finished moving about a second afterwards, we take the drive pulse away, and that stops it buzzing because you want pressure on the stock rail on the turnout. And if a servo is pushing against that, it buzzes all the time. And the trouble with the digital servos is they're too clever. You take the drive away and they say, oh yeah, the drive's gone, but I'll just keep pushing to the last setting you gave me. And of course, there's one up the other end on the fiddle yard, which is a digital servo, and it buzzes all the time in one of the positions. I haven't got around to changing it yet. Whereas for signals, I tend to recommend digital servos because you haven't got that pressure. And a digital servo is less susceptible to interference and pulses and glitches and things. So, yeah, the Cobalts are really noisy. I think you can improve if you run them off 9 volts instead of 12, but they can be better. And these are the original analog Cobalts because we're driving them off the C-bus. They're not the digital Cobalts that you drive direct from DCC.
Good, thank you. Thank you.
But of course, with JMRI, you can use whatever point motors you like. Local club layout, it's a mix of solenoids, which they'd already fitted in servos. We've done on more recent ones, and again, we're driving those. And that happens to be C-bus as well, because I'm doing it, doing the electronics. But again, we're not using JMRI there. That's just driven from a control panel.
Alan Delaney.
Yes, thank you, Mick. Pete, I'd like to know, I've got a layout that's already reasonably well developed. Can the JMRI system be added retrospectively, or does it have to be introduced at the beginning? And also, I'm particularly interested in the train detect aspect. How does this work? What I'm looking to do is I've got my points operated by Cobalts, and I'm looking to introduce semaphore signals at some point.
Okay, so there's no reason in principle why you can't add JMRI later, but you have to have a way of being able to control the points from the computer. Now, if they're on a DCC decoder, that's no problem. Which DC is your layout? DCC or analog?
It is DCC. I'm using the NCE controller.
Okay, so with NCE, you've got 2 ways you can connect it to a computer. If it's just a power cab on its own, you can get a USB interface that I think, because I think you can have a maximum of, is it 3 handsets with a pure power cab system, something like that. And the USB option takes the place of one of those power cabs. Now that can't do everything. It does have limitations on what you can control on the layout. If you've got the NCE booster, either the now what are they called? There's two. There's the 5 amp and the 10 amp one. I've forgotten what they're called now, but they have got a serial interface on the back, old-fashioned serial interface, and you can connect that via a USB to serial connector, on the assumption that pretty much no computers have an old-fashioned serial interface now, but it works fine with the adapter. And now JMRI can control any of the points that your NCE system can control. And in fact, the big West Ealing layout I was talking about, that actually was using NCE. It was using CBus for all the control of points and signals, but it was actually using NCE as the DCC system, and JMRI talks to both quite happily. So if you've got a layout that's already using NCE and you're changing your points with NCE commands, then you can link that to JMRI, and anything that you were doing from the handset or whatever before can now be done from JMRI. So certainly no problem introducing it to that. You just need the interface to the computer one way or the other, and the NCE booster is the easiest way to achieve that with the NCE system. Or it's the best way that gives you the best capabilities. I think the USB version in place of a power cab has some limitations, but the JMRI website tells you exactly what you can and cannot do with it.
Okay, lovely. Yes, I would like to discuss this at greater length, but not now.
Yeah, well, we're going to have another session after the break anyway. If we run out of other questions, we can always dive into it in a bit more depth. But yeah, it's certainly doable. Where you've got a layout where the turnouts are controlled the old-fashioned way, with direct wires from switches and things, then you've got more work, because you've got to modify that to a system that can be connected to a computer if you want to introduce JMRI.
Okay, thank you. I'll let someone else get in now. Thank you.
If somebody else wants to. I haven't got my chat window open actually. Let's have a look and see. In fact,
Nick Simpson, do you have a question?
Yes, just well, I think it's probably a quick question, but I don't know till I get the answer. I hear you talking, Pete, about scripts and writing scripts.
Yeah.
Is this a completely separate subject all on its own, or is it relatively straightforward, a straightforward thing to do and learn?
Yeah, probably yes to both. It can be a completely separate subject. I mean, the scripts are written in a language called Jython, which is actually pretty much identical to the language called Python. It's just it's running with a Java program, and there are lots of tutorials out there on the web for learning how to write simple programs and that. But in fact, the way most people start with these, and the way I started, is JMRI comes with a whole load of example scripts to do things. And so my automation script here that does these multiple trains doing multiple things started off by looking at a little example JMRI script called Back and Forth, written by Howard Watkins, which just runs one train backwards and forwards between two sensors. And I just started with that. And in fact, when we do the more advanced JMRI weekend course, we actually do that. We take that script, we make a train run backwards and forwards, and then we say, oh, well, let's change the points as well so it can go on the up line one way and the down line the other, and you build it up. So that's the best way, is you take something you know works and fiddle with it. And if it doesn't work, you know it's you that broke it, and then you can keep changing it. And that's the way most people learn the scripting. And then there's a very good JMRI forum, users forum online, where you can ask questions about, you know, how do I do this? How do I do that? Because sometimes when you're trying to do the more sophisticated stuff in the script, it isn't obvious how you might do it. And one of the experts will come back to you straight away and say, yeah, do it this way, or here's an example, or whatever. So there's very good support in that sense as well.
So in essence, what you're saying is, I did a little bit of HTML script writing, and I mean a very little bit. It's much the same as that, I'm presuming, with you're typing different characters in to represent what you want to.
Yeah, I mean, I'm still sharing, aren't I? So let me give you just to give you a tiny bit of a flavour of it. If I, what I'll do is I won't show you my script for the automation because that's quite complex and advanced. But if we go and look at, if I go and find, I'm going to find one of the example scripts that comes with JMRI, if I can work do this. Go to my C drive because it gets installed with JMRI when you install it. So I'm just going to go and find this. Bear with me for a moment. Here we go, Jython. So there's 177 example scripts. The one I was talking about here, back and forth, this is an example script. So if I just load that up. And generally you don't worry too much about some of the other stuff. This was written back in 2007 by Howard Watkins. And so what you're seeing is you're telling it, if inside JMRI you've got a sensor, because JMRI has a concept called sensors. So you need to set that side of it up first. You need to set the JMRI layout up first, telling it how to control the points, how to control the sensors, that sort of stuff. And this is the name of the sensor in JMRI, and you just tell it, I'm going to call it that in the program. And then it just, here we are, set speed as an example, set the speed setting. It works between 0 and 1, so 0.7 is a 70% speed. And you just look at examples. So a bit like, as you say, writing commands like in HTML, but it is a different language, it's Python. And whereas HTML, you're describing how something is going to be laid out on the screen. Here you're describing a sequence of actions to do, one after the other. So I'm telling it, set the speed to set forward to false, which means I'm going backwards. Wait 1,000 milliseconds, that's a second, and then set the speed so train comes back again, and you just waits for the sensors. So it's a bit of a learning curve, but you've got examples like this that give you a starting point. And I would emphasize, if you just want to use JMRI for control panels, don't be put off, because you don't need to get into writing scripts. It's only if you want to do something which JMRI doesn't do straight out of the box, as it were, that you would get as far as doing scripts.
Oh, thanks very much. I'm mainly interested in JMRI through Decoder Pro. And you intimated that earlier on. Most people do use it.
A lot of people use it just for that, yeah.
Program CVs, yeah. But it's something of interest anyway. But thanks very much for that.
Okay. One question I didn't answer, which one of you asked earlier on, was the train detection. So there are two kinds of detection you want. You want to know when a block is occupied. So, for example, this train is sitting here at this signal, and it should be going, and it's stalled. So I'm just going to go and give it a little hand of God push. This is because I didn't I didn't run out of time and didn't clean the track this morning. So my apologies. So the detectors for where the train are is detecting, this works by detecting current flowing. So there's actually an NCE do one, Merck do one, I'm sure various other companies do one, and quite often they use a little ferrite current transformer. You wind the dropper through it when you're wiring the layout, and then any train anywhere in that block will activate the detection. And so you can see these red bits here. So that means that somewhere in that section there's a train coming out here. So you can see it's now bridging both blocks, so they're both showing occupied. And then once the back's gone out of that block, I've got a little delay on there, and then it'll release that block. And that's done by current detection typically. So that method of detection does require you to insert the detector in the dropper feed so that it can detect this current flowing. And of course with DCC, there's a little bit of current flowing even when the train is stationary, because the decoder still draws enough to activate the detector. For analog, you need a different method. The other kind of train detector you want is to know when you've reached a particular spot, and you need that for accurate stopping, particularly with automation. And the ones I've got up at the end here on the left, if you see there, they are infrared detectors. So there's a little infrared detector in between the sleepers. It actually works by transmission and reflection from the bottom of the train. So that also is the other way of doing train detection. And that can be retrofitted without having to get into your wiring at all. And you could do the whole thing with optical detectors, but you'd have to add some extra logic that says the block is showing occupied whilst the train has gone past the beginning detector and hasn't yet cleared the exit detector. So the two, I tend to use the current sensing block detectors. And then you need more than just a DCC system, which can generally, in its simple way, only really control things. So you need what's called a layout control bus. NCE use their CAD bus, Digitrax use LocoNet, so you can get the feedback signals back into JMRI from these detectors.
Pete, John Gowers has got his hand up.
Has he?
Yeah.
That's worrying. Hello, John.
Yeah, Pete, just a quick question following on from Alan Delaney's question, actually.
Yeah.
Get the idea of, incorporating JMRI onto an existing layout. One of the things I presume you have to think about is if you are going down the road towards some sort of automation or reflection of where locos are and that sort of thing. The other issue would be where your brakes are or how you detect and put the brakes in for your detection on the track itself, which might be a bit more complex when you've got an existing layout that you haven't had to worry about that before.
That's a very good point, actually. Yes, if you're adding block detection. And
then add on to that,
yeah.
I noticed on your diagram that we've been watching that quite often you'll have a block, particularly in a point, you'll have a bit of a section of track that is detecting a loco because clearly it's connected to the diagonal cross bit. And I'm just wondering whether in JMRI you can actually, by changing the sections on the plan, whether you can actually get rid of that effect.
Yeah, it is possible. You could add extra logic, actually. So what you do is you put some sort of dummy sections in which you control with your logic, and you only show the one on the route the train is going. I mean, the example here was when that 158 was coming across the crossover, and I'll probably do it actually just so people could see what you're talking about. So I'm bringing it back wrong line away from the signal from this location here. And as I come onto the crossover, because this is all part of the same block, although I'm going down the crossover this way, it shows this as occupied as well, because it is. A train isn't allowed into that because we're coming across here. And so technically it's correct to show all these bits as occupied because a train isn't allowed into any of that because I'm using the crossover. For the aesthetics, you might prefer it not to show, for example, this bit here lit up whilst I'm coming down here. And you can do that, but it's fiddly. So it's a question of whether we want to spend the extra time, because you have to make this a separate dummy block and use coding of logic inside JMRI to decide whether it's going to light that up or not, depending on which way the points are set. So it's a question of whether you want to go to that level of complexity, really.
And the other question was about the sections, where to put them. You know, whether.
What? Sorry, John.
The other point was the sections, where to put them on the existing layout. Where would be a good idea? Or
so these block detectors, because they're detecting current flowing, then it only needs to have current flowing through the dropper for that particular block. So you need generally most of them you only need to have a rail break in one rail, but you do need to have breaks at the appropriate places so that you're detecting just that block. And it needs some thought about how you divide the layout up into blocks. Generally speaking, if you've got an area where more than one train needs to move at once, so you know the up line here is clearly going to be a separate block from the down line here, and so you need some thought when you're designing the layout. If you're coming up and retrofitting block detection to a layout, not only have you got to insert your detectors in the droppers, but you may have to add some extra rail brakes, get out there with the disc cutter to divide it into blocks that are going to work for you in the layout. And so there is some additional thought on that required as well. Yeah.
Pete, do you have time for one more question before the break?
I think that's a good idea. Yeah.
Okay, last question before the break then from Andrew Hicks.
Has anybody ever successfully automated shunting using JMRI with uncouplings? Even simple movements like pulling into a station, uncoupling from a train, doing a run round, picking it up at the back and pulling it off, or just uncoupling at the front and having another loco. backing onto it.
Yeah, absolutely. And people have definitely done that sort of thing, and it's on my to-do list. So what you're going to need uncouplers, probably controlled uncouplers, controlled from you generally do this from a script, I think, because trying to do that with something like the dispatcher, whilst it might be possible, is probably tricky to achieve. So you'd probably be writing a script to do the shunt move. So you're going to, whilst in theory you could have a static coupler that works when you back over it, mostly you're going to want a controllable uncoupler, which can either be electromagnetic, a solenoid thing enabled, or what a lot of people are doing now is they have a little servo, 3D printed servo thing that brings the magnet up under the track when you operate it and takes the magnet away when it's not operating, so you don't get uncoupling when you don't want to. But either way, you need to be able to control that uncoupling, and then you need to be able to do some fairly accurate positioning. So this is going to be a combination, I think, of some sensors in the right places, whether they're optical sensors or whatever, and probably some trial and error on the timing and delays and things. It's quite difficult to do it and make it very general, you know, where if you're going to back a loco onto a train and you don't know, your script doesn't know how long the train is and where it doesn't know exactly where the back of the train stopped, because it might be 2 coaches today and 3 coaches tomorrow. That's difficult because, you know, how is your script going to know how far back to move the loco, and are you going to have multiple sensors all the way down the platform? So some compromises are probably necessary. You're going to have to say, well, this is a known fixed move, and the end of the train is always going to be in the same place, so I can set my timing parameters combined with detecting some sensors. So yes, it can be done, but there are some design considerations you need to think about to get that to work, and people certainly have done it. And yeah, I'm quite keen on here with it being a terminus station. It'd be, I'm running the reason I'm running that class 33 as a push pull is I could realistically run it backwards and forwards, and I've got a DMU there, but it'd be nice to be able to haul a few coaches in with a loco, uncouple it, put another loco on the other end, or potentially do a run round or something like that. And that's all achievable. And it's a question of trial and error and fiddling around with it to get it to work the way you want once you've got the control hardware and sensors that you need, I think. But people have certainly done that sort of thing. It's certainly on my to-do list. So.
Okay, Pete.
Hello, Pete.
Hello.
Alan Wright. Just a stupid question, I suspect, but when you were talking about the block detection and using current, whatever.
Yeah.
This may be a silly question, but obviously each block is electrically insulated from the next block on both rails.
Oh, not necessarily. You only need to isolate one rail.
That's
because you detect the current. The detector just goes in one dropper, detects the current passing through the dropper of one rail. So you choose which rail you're going to detect, and you only need to break that one.
Oh, got you. Yeah. Okay. So it's not a case that you've got separate wires running from your boosters or anything like that to each block.
No, not at all. In fact, I have a picture I can show, which was taken for a different reason, but it actually shows this, I think. Give me a second and I'll see if I can find it, and then I'll share my screen. Give me a moment. I think it's, I'm just finding the photo in question. Yeah, this is probably. Right, I'm just going to share my screen again. So this is the underneath of part of the throat end of the fiddle yard.
Yes.
So the main DCC bus is the orange and blue wire down the middle. So the dropper wires, for example, you've got your blue dropper wires just come directly to the DCC bus. These are the servo point motor mounts, and these are the C-bus modules that control it. Now I've got a convention that blue is one side of one rail and orange is the other rail, called tracks. So I'm detecting the current flow in the orange rail. So what happens is this dropper here, instead of going straight to the DCC bus, goes via If we follow this round, it's not exactly wide the neatest, but there we go. And actually, let me just follow this one. Let's take this wire. This orange wire here goes via this detector. And basically the dropper effectively gets wound round this current transformer and comes back and then goes to the DCC bus. So it's not coming direct from the booster, it's just coming from your bus. And then what happens is this module, when it detects a current flowing in that dropper wire, by virtue of it being wound round here, it sends a message on in our case on the C bus, it was an NCE, it'd be on your NCE cab bus, which JMRI picks up.
Right.
Does that help?
Yes, it does. Yeah. Yeah. Okay. Yeah, that helps. Yeah, of course.
So it's only the orange side rail that I need to make sure. I need to make sure two things. I need to make sure that all the droppers that feed that block, because it could be multiple track segments, each with their own dropper. So I'll bring those droppers together and then take them through the block detector and then on to the bus. So I need to make sure that all droppers that feed that block go through the same detector. And I need to make sure that there's a rail break in the orange rail at the boundaries of the block. And also you would tend to make block boundaries at baseboard boundaries because you don't want to be running extra wires across the baseboard joint, of course.
No, that's fine. But yeah, and you'd always have to use, in your case, the orange wire side of the track.
You don't have to always. If for some reason you'd either due to on West Ealing there was a cock up that I made at one stage, so part of the layout's on one rail and parts on the other. As long as you've got a double rail break where you change over which side you're detecting, it doesn't matter.
Okay. Yeah.
And then with frogs, what you do is the frog feed, which is the yellow wires here, goes to, let me remember how we've done this on here. So you've got a micro switch. The frog feed goes straight to the micro switch in my case on the point motor here, and the orange side feed to that micro switch goes through the same block detector as the rest of the block that points in. So that makes sure that your the frog current is being put through the detector when the frog is switched to the orange rail.
Yeah, that would be important because that's part of the line, isn't it?
It is, yeah, absolutely.
Yeah. Okay. No, thank you for that. That's very good.
Okay.
We had a question from Graham Stacey, Pete.
Yeah.
On turnouts, one if you use frog juicers and any merit in using them.
Yeah, I'm not a fan of the conventional frog juicers that work by having a short circuit and correcting it, because you're always going to get that spike when you get a short circuit. The other thing you've got to be careful of is if the frog juicer is being powered from the track, you've got to make sure it's not taking power of a route that's through the block detector, because otherwise it's going to think there's a train there all the time. So you have got to think about that, and it can be done. You've got to make sure the power for the frog juicer is not taken through the current sensor, and so it does take some extra thought. One of our MERG members has come up with a rather neat design of an automatic frog polarity thing. You could call it a frog juicer, but it doesn't work by waiting for a short, by putting it one way and waiting for a short and switching it the other way. The way it works is that the frog sits there dead, and then when the wheel bridges onto the frog, that momentarily puts the correct voltage onto the frog, if you like, as the wheel bridges, and the circuit detects that and switches the frog to that voltage. So there's never a short circuit. That's quite neat. And again, you have to be careful how you wire that if you're using this type of detector. I mean, one clever trick you can do is, where are we? Instead of doing it the way I've done it here, which is where the frog goes straight to the feed, goes straight to the micro switch, and then you take the correct side of the feed to the micro switch, is you could instead not take either of the feeds to the micro switch through the sensor, and instead you take this yellow wire and you put a second turn around the same detector coil. So if you're using the detector coil type, you can put another turn around it just from the frog wire. So now only when current is being drawn from specifically through that frog dropper will it activate it, and then your frog juicer circuit would power directly off your DCC bus, and so its power wouldn't be going through your detector. So, but it is some things to think about. Yeah, definitely.
Thank you. Thanks.
Any more questions there?
I see no hands raised. I see no unmuted microphones.
Okay, well, John asked if we ran out of time for other things, whether we could talk about RFID detection. Is that of interest to people? I'm not seeing yeses or nos, but I'm getting a few nods. Okay. At the moment, we've been talking about train detection, and we have to start by telling it which train's where, so at least it knows which train it's working with. Now, it is possible to actually identify a train by putting, one of the methods for doing that is RFID. That's the same technology as the little tags on all the supermarket things and so on. And the ones we're working with now, I've been experimenting with, they're actually little stick-on tags that you stick on the bottom of the loco, and they seem to work quite well generally. So what happens is that you stick one of these tags on the underside of each loco, and you have an RFID reader. And let me just find, if I just go on my photos here, there we go. This looks quite complex because I'm experimenting with a number of different things here. That's why these little black things here are the RFID readers, and they're connected to this module here, which is doing the RFID reading. I've also got an old version of RFID, and I've got a thing called Railcom here. So you wouldn't necessarily need all this electronics just to work that fiddle yard normally. This module here does everything else. It works all the point motors. It brings in all the detections from all the lock detectors. So that's kind of doing everything you would normally need. This is add-on for train detection. So on the two tracks on the fiddle yard there and there, I've got one of these little readers, and it's just stuck on the bottom of the baseboard and detects the tag through the baseboard and the phone. And in fact, it's located, I think it's about here and about here, those two places. And then when a locomotive with one of those tags on the bottom goes over the reader, JMRI reads in the value, and I've got some things here where it puts the value. Steve Young is still doing some work on JMRI for our C-bus RFID reader system to make it work just the way we want it to. What the idea is that it can then fill in this value that I had to type in automatically as the train passes over the reader. There's a little bit of a chicken and egg catch-22 type thing there, is that for JMRI to be able to drive the train automatically, it needs to know what the train is. But for it to automatically identify the train, you have to drive it over the reader. So you'd have to manually run the train over the reader first before JMRI could drive it automatically. If your normal procedure is to put the trains on in a certain place and then drive them into the fiddle yard, for example, then you could have that identification happen there. It saves you typing it in when the operation starts, if you like. That's just one thought to throw in. And then I think that, there are other systems out there with RFID, and some of the American people there's a whole part of JMRI I haven't even touched on called operations, which American modelers use a lot, and that's about tracking wagon loads. So you got your 100 wagon or more American freight train, and every wagon is being tracked for its. So you have the consist of the whole train, and you're tracking those wagon loads from place to place. And that's part of what they do with operations in JMRI. And you can, in theory, have an RFID tag on every single wagon, so you can identify every wagon as it goes over the reader. Something else you can use with JMRI. Just for completeness, there's another mechanism of identifying a loco called Railcom, which certain decoders will do, not all decoders. The more upmarket decoders, Zemo, ESU, and so on, will do Railcom. And what that means is that there's a mechanism whereby the locomotive can actually transmit its identification back over the DCC, because the DCC has a very brief break in the signal, without going into too much technicality. And so if you've got a command station and or booster that will work with this Railcom system, because it has to be compatible, and the decoder in the loco is capable of doing it, and the features turned on, then you can have it identify itself that way. And that's the other thing I've got here. This other module here is an experimental railcom module that's actually reading. So those trains that have a railcom ID, and there's still development going on as to exactly how that formats the data and transmits it back to JMRI. So from the C-bus perspective, that's fairly new. So. John, does that cover what you wanted me to talk about in terms of RFID? Or John's obviously not active or muted or something.
Well, he's muted.
I've now decided that actually what I said was a load of rubbish anyway. No, I'm just saying. I was saying not everybody may know what RFID stands for.
Oh, sorry, what it stands for: radio frequency identification. And it's the technology inside it is that the reader sends a radio signal which wakes it up and activates it and actually powers it, so that the tag can answer. And so it's how the supermarkets mark all their stuff, which is why it's so cheap now. When this bubble car comes in, I'm going to hold it up and show you the tag underneath. So I'll stop my actually I can hold it to this camera probably. Yeah, you can probably see that then. The little tag is just there, and it's a little sticky label, comes on a strip of sticky labels, and you just find a little flat area. And I think you can get smaller ones that might work with N-Gage. So here we go.
I think Frank Barrett might have a question, Pete.
I do.
Yeah.
Hi, Pete.
Hi.
Hi. I've got an existing layout, but I'm still analog. So, is there anything with JMRI that I can actually use, or really am I talking about making the change to a DCC layout?
Well, and how are you controlling the points and all signals at the moment?
I've got tortoise point motors on all of them, and like a double pole, double throw switch.
So you're controlling them directly, yeah. So as it stands, JMRI can't control anything on your layout because it has no way of connecting. So what you would need to do if you wanted to be able to use JMRI is have some mechanism of, if you want to be able to have control panels to control the points and signals, you've got to have a mechanism of actually controlling the point motors and the signals. And so that means either, now it doesn't mean that the trains have to be DCC. You could run a DCC bus round and have DCC decoders, just static decoders, just for the points and signals, and leave the track being analog. You could use something like Locanet or the Merg C-bus system, as we've done here. And so you run the C-bus around the layout, and you have C-bus modules that link to the point motors and control the point motors and the signals. And you could so you could take your existing control panel and instead of the wires that go direct to the points, you could replace that with another module, in our case a C-bus module, that would take those switch inputs, and you could set it up so the switches still work the same points as they do now. So you still have your physical control panel, and then in parallel with that, and that's what I've got on Missenden St Mary's here, in parallel with that, you would have a module on this C-bus, and it would reduce the number of wires going around the layout considerably. And now you could then put an interface to the computer and JMRI, and now you could have a control panel like the one we see here to control the layout, points and signals. If you want to be able to drive the trains, from my experience, I would say yes, you'd probably want to go DCC with the trains. In theory, there are ways of making it drive analog, but it's something I don't know anything about, and I think it's relatively not that straightforward to do, because it's kind of designed around DCC in terms of actually driving trains.
Right. So,
but it's pretty powerful, even just controlling the layout with it. You know, there's quite a few layouts I've been involved with where there's no attempt to have JMRI actually drive the trains. It's just, you know, it's all about controlling the layout, the signal points and signals, and setting the routes.
Yeah, I'll be honest. From what I've seen, you know, it's the having that control panel and being able to control the points and signals, and that is quite appealing. And what's going through my mind is, you know, I know I've got to. You know, I haven't got to, but I know I should make the move from analog to DCC. I'm just wondering whether moving to JMRI first is the right step, as opposed to going completely converting everything to DCC and then using JMRI. You know, it's whether there's a benefit in going which direction. You know.
I think you could do it any of those ways. I mean, there's no requirement to go DCC. You know, plenty of people still with analog layouts and happy running them that way. So, but if you'd like to be able to do the sort of thing I'm doing here, then ultimately, yes, you'd look towards having trains that you can control, and going DCC would be the way to do it. See, if you run a DCC bus round initially to connect to everything, then you can change it over. Now, it is possible to take an analog layout. What sort of size layout are we talking about?
It's only a small branch line terminus.
Yeah.
Where it's about 9 foot length. You know.
So with a relatively small layout, this would work okay. With larger layouts, you can get into problems, but with relatively small layout. So what you can do is, are you using sort of kind of like a cab control system where you how many analog controllers do you have?
I've got two gauges.
So you have presumably a switch for each section, which will switch it to one controller or the other.
So each on the panel, I've got a switch to control whether it's on using controller A or controller B. You know, so I can alternate. Exactly. So at least in theory, I could get two locos moving.
Yeah. So what you can do, so it's not ideal wiring, but on a small layout, it's going to work. If you switch every one of those switches, shall we say, to controller A, and then connect your DCC command station stroke booster into where you currently connect your analog controller A, you now have a DCC layout, because that command station signal is now going to every section. It's not how you would wire it for DCC, because the current signal for every single loco is going through the control panel, but it'll work on a small layout. It should work fine. And so then you've just got the not necessarily inconsiderable job, depending on the size of your fleet, of fitting DCC decoders to all the locos.
Okay.
And if they're not DCC ready, you can still fit a DCC decoder to it. You just got to hardwire it in, so a little bit more work. But if they're DCC ready, it's just a case of plugging decoders in. I've
probably got about I think 2/3 DCC ready and a third are not. So
once you've done a few, it becomes fairly straightforward. So,
Okay, all right, that's something to think about. Thank you very much. Thanks, Pete.
Pete, we have a question from Alan Delaney asking if you can say a word about designing the mimic panel on the screen.
Right, a word. Which word shall I use? So this is the mimic diagram we're talking about here. So I tend to just do it on screen. I mean, a lot of people will tend to sketch it on a bit of paper first. And of course, it tends to be, you know, a representation signal box style, rather than trying to, I don't try and put the accurate curves or anything like that in. It's a representation as you'd have in a signal box. And JMRI, I use a thing called the layout editor, which is what this is done with. And in edit mode, it looks like this. And in fact, let's, rather than doing that, I've got a better idea. So if I were to go to my main JMRI window, control window here, and I'm going to say a new panel, I'm going to create a new panel with the layout editor. And this is what it looks like, a blank control panel. And now working with the layout diagram, or just looking at my layout, and again, when we do the course, we go into all the details of how to do this. I can just add turnouts. In fact, what I'm going to do is I'm going to work zoomed in a bit, because it's easier to see what's going on. So I've got a turnout there. Actually, let's, I guess it has this habit of messing around with the That's okay. That's all right. Yeah, it extends the grid and that automatically. So I can rotate that if I want. Rotate that by 180 degrees. I can put that there. I can drag these little things. Now there's some snap to grid things I can use, which actually makes life a lot easier. I can't remember. There's shortcut keys for a lot of that, which I forget in my dosage. Here we go. Grid options. Control Shift A and Control Shift M. So now it's snapping to my grid, which makes life easier when I'm setting it how I want it. So I can. These are the turnouts here. And now I can do a track segment. I can join these together. I didn't do that very neatly, did I? But anyway, I can fix that afterwards. That's better. And now if I come out of edit mode, I've drawn a bit of a track diagram. So once you get the hang of the different keys to use and how you drag and click and so on, and then what I have to do is there's a mechanism in JMRI to actually tell it which turnout. I basically, for the real turnouts, if it's DCC, I would tell it what the DCC addresses are for each. If it's CBus, I tell it what the CBus events are for each. But basically you build a table of all the different turnouts, giving them a name, and then you can tell it which physical turnout this corresponds to. So you get to a point where I can click on it and I can change the point. And you just build up your layout diagram like that. And there are a lot of different features you can use. So you end up with something that looks, and you can see this one's just a default grey background. You can change background colours, have a background photo. You have these sensor buttons that make things happen. You link in here, you link it in with the sensors coming in from the layout if you want block detection and so on. So you build it up like that way. Is that sufficient of a word just to give you a flavour of where you go with doing the mimic diagram?
Yes, thank you very much. It already looks very similar to a track design package that I have already. Thank you.
Okay, yes, you'll find that it probably is similar in some ways, but probably uses different keys and different mouse buttons for everything, which can be confusing when you first start using it.
Yes, thank you.
And there is, for those using AnyRail to design a layout, there is a facility to export from AnyRail, import into JMRI. Of course, it may not produce what you want, because whereas AnyRail, you're tending to do an accurate, plan of your layout with all the curve radii and everything, whereas you tend to want a schematic type diagram, signal box type diagram for JMRI. So I don't tend to do it that way. I tend to just knock up the diagram in JMRI the way I want it, but that's another option that is open to you. Any more
questions from anybody? I've no outstanding chat questions. Oh, Andrew,
what's for lunch?
Last question, Pete. Can JMRI handle block and bell code signaling or any other form of communication between operators on a layout?
Well, it's not built in to JMRI as standard, but you could. The thing about JMRI is, with a combination of what's called logics, which is a logical thing, you and the scripts, if you need them, you can make it do pretty much anything. So yes, you can. People have done that sort of stuff with it. So it's not a built-in feature, but you could certainly make it do it, because you can have it. You can have it play a particular sound when a particular sensor goes active, and you can have a button at one end, or indeed you could have a physical bell telegraph system that is linked to JMRI as a sensor, can go down your layout control bus to the other end, and it can flash a light and or make a sound which is a bell, or indeed it can activate an output which drives a real bell. So you can do all those things. It's just you kind of got to roll it yourself using the facilities that JMRI gives you. Okay.
Well, it looks as if everybody's fairly happy with what you said, Pete.
Hopefully so. I mean, one thing about JMRI, there is a lot to learn. And one of our members once described learning JMRI as like taking a drink from a fire hydrant. There's so much information out there, which is why we run the courses, of course, to bring you in gently.
Well, if there are no more questions, then I'd just like to say thank you very much, Pete, for your time and trouble.
My pleasure.
And say cheerio to everybody, just knowing that I'll see some of you in an hour or so's time.
Which is the next presentation? Can you remind me?
It's 2 o'clock this afternoon, and it's Tim Watson showing off his workbench.
So I trust he hasn't cleared the workbench for the purpose.
I think what he's actually done is moved part of his workbench into the conservatory.
Okay.
Okay, thank you very much.
Thanks, everyone. Thank
See
you.
you at the next session.
See you later.
Much appreciated.
Thank you
Bye.
very much, Pete. Very good.
Okay.
Thank you, very much appreciated.
Bye now.
Catch you later.
Bye now.
Thanks, Pete. Bye.
Okay, cheers.
Good job, Pete.
Thanks.
Shows promise.
No heckling from you, Chris. What happened?
No, I've been busy, but I didn't feel it was appropriate. I mean, there's a couple of pointers I can give you, but
Thanks.
No, it was really good. Grand job. See you in a bit.
Good. Cheers.
Cheers, all. Bye.